Hey everyone, let's take a look at an example that looks at these internal forces. And so what I've got here is a beam, and at point A it's being supported by a pin support, and at point B it's being supported by a roller support. And then I've exerted a force of 125 newtons on the far right hand side. And what I'm interested in is what's going on at point Q. All right, so A and B are separated by 8 meters, but from A to the right hand side of the beam is 10 meters total. And then Q is 4 meters away from point A. So how do I solve a problem like this? Well, the first thing I'm going to do is I'm going to ignore the fact that I want to know what's going on at Q. First thing I do is I figure out what's going on at A and B. And so I have a pin support at A, and so it's going to exert a force A sub X and a force A sub Y. And then B is a roller support, so it can only exert a vertical force upwards, and so that's going to be some value B. And once I've got these forces on my diagram, now I just do my force equations, right? So the sum of the forces in the X, I have A sub X, and that's all I've got, and that's equal to 0, right? The sum of the forces in the X are 0. And then the sum of the forces in the Y, I have A sub Y minus F, and that's equal to 0. And so A sub Y equals F, but F is 125 newtons. And, oh, that's not right. So wait a minute. So I've got A sub Y plus B minus F equals 0. So A sub Y plus B is equal to 125 newtons. All right, so I don't know two things there. A sub X I've gotten, but these two unknowns. And so I still need to do the sum of the moments. And to make my life simple, I'm going to take the sum of the moments about point A. That just eliminates A and X and AY from my equations. And so I'm going to get B times 8 meters. And that's going to be counterclockwise, so that's positive. And then 125 newtons times 10 meters, and that's going to be clockwise, so that's negative, and that's equal to 0. And so I get B is equal to 1250 newtons, 1250 newton meters over 8 meters. And so that's going to be 5. What have I got there? 1 here, that's 45. So then 50 is 6 1/4. So 156.25. No, I've done something wrong. All right, let's see. 1250 divided by 8. 8 goes into that once. 45. 8 goes into that 5 times. Oh, yeah, I see what's going on. No, 156.25 is right. And then, okay, so that's B. So what's going on then at A? So A sub Y plus B equals 125 newtons. But B is 156.25 newtons. And so A sub Y, I'm going to get 2531.25. So A sub Y is equal to 31.25 newtons, but that's down. So that's negative. And if you think about it, that actually makes sense, because 125 is pushing down. B is like the pivot point, so it's trying to rotate in this direction, right? And so in order to stop that from happening, A sub Y has to pull down. Okay? So that worked out pretty nicely. So negative 31.25. Now, what I do is I make my cut. And then, like I talked about in a previous video, I treat the cut as a fixed support. So it's going to apply a Y force. And by convention, this is left of the cut. I've drawn this out with the cut on the right-hand side. So by convention, I put V down, and then F That's what your book is calling this. I like to call it P. So let me just change that, if for no other reason than I've got another F in here already. So this axial force P is to the right, and then M is the moment applied by this fixed support in the beam itself, right? So every cut is a fixed support. But I do have forces at A. I have A sub x, but that was equal to 0. And so you can see that the P is going to equal to 0. So let's get that out of there, because we really don't need it. A sub y is down, right? So this is 31.25 newtons, assuming all my math is correct. And I'm not going to worry about it, because that's just calculated work. And then there's a moment M. And then this distance in here is 4 meters, right? There's 4 meters in here. And so in order to solve this out, I just do force and moment equations again. There are no forces in the x, so that's a done deal. So but there are forces in the y. So if I look at this, I've got right, the sum of the forces in the y. Sum of the forces in the y. I've got minus 31.25 newtons. Minus v is equal to 0, because this v by convention is down. That doesn't mean it's going to always be down. In this case, it's not. And so v is equal to minus 31.25 newtons, which means v is actually pointing up, right? Again, by convention, I have it pointing down, but in reality, it's going to be pointing up. Not a big deal. But what about this moment? So if I do the sum of the moments about A, right, then I don't need to worry about that. I'm going to end up with 31.25 newtons. Well, let me draw it out. Let me write it out. So V is pointing down. That's going to be clockwise. So minus V times 4 meters plus M is equal to 0. All right, but V, well, okay, so let's solve this out then. So M is equal to V times 4 meters. But V, remember, is negative 31.25 newtons, and then 4 meters. And so, what do I get there? I get 120, 124, 125. Right, so I get 125 newton meters, and that's negative. And so, what I take from this then is that M is going to be clockwise, not counterclockwise. But that makes sense because V is in reality is up. So it's trying to rotate it this direction, and it's not going to let it do that. So it's got to apply a counterclockwise, or excuse me, a clockwise moment. So V in reality is pushing up. So V is trying to rotate it counterclockwise. So M has to counter that and try to rotate it clockwise. And so that gives me the value for the moment. Now notice this value for the moment depends on this 4 meters. And so what we're going to do in the next video or a subsequent video is we're going to look at this for some arbitrary position and see what we end up with when we do that. All right? So if you have any questions on this example, please do leave them in the comments below. Thank you.